I hope you all had an opportunity to grab some water and stretch your legs. Thank you so much for joining us today. I've really been enjoying all of your wonderful questions and feedback. Welcome to our next session, From Data to Deliverance, Leveraging Research to Inform Post-Conviction. Today, we have two wonderful presentations that will illustrate how data can be used to assist post-conviction litigation and intake decision-making. I'm now going to kick it off to our first presenters, Ayub Ibrahim, Ree Deo, and Rajiv Sinclair.
All right. Hello, everybody. We're here today to talk about what we've newly dubbed the Innocence Discovery Lab. But to do that, we have to start with LEAD. LEAD is the Louisiana Law Enforcement Accountability Database, which is an open source platform that seeks to aggregate law enforcement data from all agencies in all parishes, that's counties for the rest of y'all, in Louisiana. The database currently contains data from over 600 agencies, 95,000 individuals, 4,200 articles, and over 1,950 documents. And these will be ever-growing numbers as we expand the breadth and depth of our public records requests. The data sets include biographical information, employment history, press, and misconduct allegations. Importantly, we can now track not only histories of misconduct, but also officer migration. LEAD's data forms the foundation of the Innocence Discovery Lab, where we seek to use large language models to extract data from the vast trove of wrongful conviction documents, which are unstructured data that would take humans otherwise years to process.
So the intention behind this research is to build an auxiliary database to supplement the data that we've been able to receive from law enforcement agencies across the state. What we're doing is focusing on our stage 4 case files. Specifically, we're analyzing the case files of 49 exonerated clients. After internal review and discussion, we narrowed our focus to 2 types of public documents, so documents that are subject to the Public Records Act. One, we're focusing on police reports. These are primary documents that offer initial narratives from law enforcement's perspective. They provide a record of the officer's involvement, action taken during arrest, and subsequent procedures. We're also focusing on court transcripts. These are records of court proceedings capturing the exact words of the officers when they stand as witnesses. Officers typically appear as witnesses to describe their roles in the conviction, including making the arrest, transporting evidence, and interrogating the accused.
Hints from IPNO's case history. So here you see 2 IPNO clients, Raymond Flanks and John Floyd, both Orleans homicide cases, each exonerated after more than 35 years in prison. The same lead detective, John Dillman, was instrumental in both of their wrongful convictions, coercing witnesses in Raymond's case and forcing a false confession from John. We know from studying wrongful conviction cases that the people involved in those wrongful convictions show up in other cases. But how do we find them? Who did they work with? What other cases were they involved in? And what roles did they play in all of those cases?
In order to analyze and investigate these patterns, we need to work with data or structured information. The various documents that we're starting from contain many different types of information scattered throughout a mix of long sentences written or sometimes transcribed from multiple different perspectives, and various reports or forms that are based on inconsistent templates. Also, most of these documents began as pieces of paper that needed to be scanned into image files and then converted into text files before we could even begin processing their contents. Next, once we have the text, we need to extract all of the important information from the unstructured texts so that we can generate usable data, i.e. rows and columns, or something like a spreadsheet. A simplistic approach using a tool like regex would be the most obvious way to do this, perhaps. Regex functions deterministically by following strict rules and predefined patterns. For example, every time that the text says accused officer, then the text that follows that is presumed to be the name of an accused officer. This is great because it is 100% predictable, but Unfortunately, our source material is not so straightforward or consistent. That's why we have instead decided to use large language models, or LLMs, for this purpose. Ayub?
So large language models are statistical models that are trained on enormous bodies of text from all over the internet. These models typically use neural networks to take input text, referred to as a prompt, and then predict the text that will follow next. For example, if I input a prompt saying Rajiv is wearing a blue shirt today, what color is Rajiv's shirt? The model would then predict the next sentence, or the next iteration of the model's output would be something along the lines of Rajiv's shirt is blue. Because large language models are so efficient at predicting text, by extension, they're also proficient in identifying text based on a set of rules. What we're using large language models to do is generate spreadsheets that contain at least 3 columns. 1, the name of the officer. 2, the context, which is an in-depth description of the context in which the officer was mentioned within that document. And 3, the role, which is the role of the officer within the specific context of the document. I'm sure, as many of you know, there are plenty of limitations associated with large language models. 2 of the most important for our purposes are data quality dependence. So large language models, the output of large language models is highly contingent on the input data's quality. Therefore, poor data quality can lead to misinformation and errors in pattern recognition. There's also a large issue in terms of bias. Large language models inherit biases present in their data training LLMs inherent biases present in their training data, potentially reflecting historical prejudices in their outputs, which is especially concerning in the context of legal applications.
But what investigative possibilities might these tools offer to us? And to do that, I think we have to ask ourselves what new questions might not be answered after we're able to extract the identities and the roles of every law enforcement officer involved in every wrongful conviction case. What trends might appear? For example, that Division X in Department Y during time period Z was involved in a number of wrongful conviction cases. Or that Neighborhood A was over-policed and patrolled by officers B, C, and D during a period that produced E number of known wrongful convictions. What if we can then run network analyses against the LEAD database and IPNO's case management system to not only find cases, but maybe classes of cases affected not only by the known bad actors, but the officers they partnered with, were trained by, or were named with them in misconduct allegations? Did they take their worst practices with them when they migrated from one law enforcement agency to another? These are questions, the answers of which have been buried in this data and might now be asked and answered once we unearth them.
There are a few challenges that we've encountered so far. One is the quality of the raw documents that we're working with, of course. Unfortunately, these documents are very inconsistent, and this sometimes leads to imperfect transcription into text. When the text is transcribed incorrectly, it can reduce the accuracy of data that is extracted from that text. Another factor, of course, is cost. GPT-4 is a larger and more sophisticated state-of-the-art LLM, or large language model, so it's very effective, but it's not very efficient. It is expensive, and those costs can become burdensome as the scale of the project grows. In order to optimize costs, we are developing a fine-tuned version of the GPT 3.5 model, which is more efficient and much less expensive. Through fine-tuning, we can tweak the model to be more optimized for our specific use case. This process requires first that we create a training data set that informs the fine-tuning process. Lastly, I'll just quickly mention that consistency and reliability at scale remains a challenge, especially as we seek to balance all of these trade-offs. For example, our system runs each query several times and then compares all of the results to make sure that it is consistently extracting accurate and comprehensive data. This is because even in the most conservative configuration, these LLMs are based on a statistical prediction, and thus they are not deterministic. So they will generate a different, slightly different, or sometimes not so slightly different response each time that they're run. Over the aggregate of several runs, however, their distribution approaches a mean, which is perfectly usable as data for purpose of investigation. Ayub?
So we have 4 next steps. One is improving the document quality. So in the future, we plan to apply LLMs to enhance the text quality of documents that have been poorly transcribed through OCR. This is a huge issue, especially when dealing with historical data or historical documents that go back 10, 20, 30 years. We're next exploring ways of cost optimizing GPT-3. As Rajiv pointed out, GPT-4 is about 29 times more expensive than GPT-3. To that end, we've been experimenting with fine-tuning GPT-3. We're currently seeing about a 0.10 increase in performance, which is a performance level which is on par with GPT-4. We hope with additional fine-tuning, we can have GPT-3 can actually be better or perform better than GPT-4. At extracting officer data from these documents. We intend to broaden the data spectrum. Currently, we're expanding our data set to encompass a wider variety of factors, including use of force incidents, settlement records, and stop and search data. Additionally, we plan to diversify the types of documents we analyze, which will now include memos, news articles, and social media content. And then the last next step that I'd like to touch on is toolkit generalization. Our ultimate goal is to create a generalized toolkit that can be adapted for various data types and documents. This tool will hopefully be invaluable for extending our efforts beyond our current jurisdiction in Louisiana, thus enabling any organization with similar objectives to leverage our findings and methodologies.
So to reiterate a bit, from the start of LEAD, as well as the Discovery Lab, it was important to us that we develop these tools as open source so that they would be exportable and scalable to fit the needs of others, especially others who will be feeding these things different kinds of data. But for the Innocence Network, for those who are doing casework, there are specific opportunities, and again, these will take the form of questions that we could only ask before that now actually might be answered using big data. So what I've listed here is a better ability or more effective way to prioritize known cases, that is the cases already in your queue. What if you could process the documents in one case, identify the law enforcement involved and the roles they played, and then we're able to link them to other cases, both known wrongful convictions and the other cases in your queue? What if you process the documents and law enforcement personnel in old cases that have hit a wall and find new avenues of investigation to reopen them? What could change if you learned that the same crime lab analysts, for example, were involved in a number of cases waiting for investigation in your own shop? Beyond what's already in your offices, what might change if you could prospectively go and find cases after identifying all of the officers, the ADAs, the crime labs, and attorneys involved in all of your known cases in your queue? What if you need to identify classes of cases to prove pattern and practice in a case that you're already investigating or representing? For the researchers and policy folks, what opportunities are there for you to move communities, academia, press, courts, and lawmaking and policymaking bodies when you can connect wrongful conviction data in a meaningful way with law enforcement writ large? How can your positions be strengthened when advocating for righteous change if you can connect real and comprehensive law enforcement data to demographic data, to fiscal data, to crime data? The tools developed by the Innocence Discovery Lab will empower people to find hidden actors and trends, to connect data to people, to cases, to see cases through new and powerful lenses, and in the end, more effectively advocate for communities and those we seek to serve. Thanks, y'all.
Awesome. Thank you, Ayub, and Rajiv, representing Innocence Project New Orleans. If you have any questions for these fine folks, make sure to put them in the chat and we will get to them later. Our next presenters are Kalina Tizin and Carl Wiedemann. Over to you, Carl and Kalina.
Thank you. Okay. Hi, everybody. So I am Carl Wiedemann, and I'm presenting today with Kalina Kostishin on our work titled A Computational Decision Tree Approach to Inform Post-Conviction Intake Decisions. I'd like to just make a special shout out to our other co-authors for this project who work with us at Stony Brook. Their names are, let's see if I can get these slides up. So their names are Rosa Bermejo, Amy Page, Kristen Kalb de la Rada, Nancy Franklin, and Susan Brennan. So a problem that is faced by intake staff at various innocence organizations throughout the United States is that they receive an overwhelming number of applications. And intake staff must determine if there is enough evidence to move any applicant forward to the next step of the intake process. However, they're challenged by a couple of limitations, those being that resources at various innocence organizations are limited. The applications themselves can be wildly inconsistent with one another. As you've just seen in the previous presentation, there is quite a bit of documentation that can be associated with a particular case. And so some applicants can contact the innocence organizations with a wealth of information that's very difficult to sort through, and some other applicants unfortunately do not have the resources with which to provide enough documentation to an innocence organization. And so the decisions on who to take on are extremely difficult to make. So our ultimate goal was to use data analytic tools to develop a transparent and user-friendly framework that can support these difficult decisions in the intake process. And I want to emphasize here that we're not talking about making a framework that would make decisions on its own on behalf of a human being, but we're seeking only to make an assistive framework that can benefit these already experienced decision makers in the challenging task that they're faced with. So one way in which we can start to approach this problem is by using data from prior successful exoneration cases, which is collected in the National Registry of Exonerations database. So each case in the NRE database includes at least one of 6 canonical factors which are known to contribute to wrongful convictions, those being mistaken witness identification, perjury or false accusation, false confession, false or misleading forensic evidence, official misconduct, and inadequate legal defense. Now, many cases within the NRE database include more than one of these factors, as they can frequently co-occur with one another in the real world. And so in exploring the National Registry of Exonerations database, there's a number of different statistical techniques that we can use, one of which is known as the latent class analysis. So a latent class analysis is used to identify latent subgroups within populations. And by latent, what I mean is unobservable. Now, this is very similar to when psychologists use a factor analysis to tease apart questions within their psychometric measures. So, for example, if a psychologist were to give somebody a questionnaire about depression, some of the questions on that questionnaire might relate to anxiety symptoms, and some of the questions might relate to depressive symptoms. And a factor analysis would be able to tease apart which questions relate to which types of symptoms. Similarly, a latent class analysis can be used to uncover implicit patterns within a large data set, such as the NRE database. So you have all of this wealth of information on thousands of exoneration cases from the United States, and the latent class analysis can break down all of this data into allowing us to see otherwise unobservable patterns within the data by associating every individual with their most likely membership within a particular latent class. So variables such as the 6 canonical factors can be used as indicator variables for this type of analysis. Now, in last year's inaugural Just Data Research Conference, we were particularly fascinated by Ryan Berrubi's presentation on a paper that she worked with her colleagues called Identifying Patterns Across the 6 Canonical Factors Underlying Wrongful Convictions, in which they presented their application of an LCA to the NRE database to examine patterns across these 6 canonical factors. And in doing so, they identified 4 latent classes. those being investigative corruption, failures to investigate, witness mistakes, and intentional errors. So essentially what they're doing is taking the data on all of these different past exoneration cases and attributing each individual to be most likely to be attributable to one of these four underlying classes. So moving forward, we want to know, most importantly, if these original LCA results replicate before we do anything further with the results. So Ryan Berube and her colleagues' LCA was conducted on data from November 3rd, 2021, at a time when the database had 2,880 cases. But as of April 26, 2023, when we began our investigation, there were 3,284 cases in the database. So it's important to know if the trends that were observed by Berube and her colleagues are robust with the addition of hundreds of additional cases to the database. Now, also moving forward, if we're able to determine the robustness of the data and use the LCA results confidently, this can inform a more transparent approach called the decision tree algorithm. And the benefit of a decision tree algorithm is that these algorithms can transparently decompose the complex patterns within the NRE database that contribute to each individual's probability of being assigned to a particular latent class. So we can understand exactly why individuals might be broadly grouped together within the category, for example, of investigative corruption. So before I move on to talking about the decision tree application, I just want to show the results of our replication attempt. So Berube et al.'s original LCA is presented on the left at the time, again, when there were 2,880 cases in the database. Oh, sorry about that. And so Berube et al.'s original LCA, again, is presented on the left, and our replication attempt is presented on the right at a time when there were 3,284 cases within the database. And you can see that the patterns in both of these analyses are largely similar to one another, with only minor variations in the percentages of representation in each latent class. So the underlying patterns that were originally observed by Berube and colleagues appear robust, even with hundreds of additional cases in the database. And what's great about this is that now we can take the LCA replication results and use them as a target for our decision tree analysis. So I'm going to turn over the rest of the presentation now to my colleague, Kalina Kostishin, who has done, I think, a really excellent job of forwarding our efforts to assist with these intake decisions.
Great. Thank you very much, Carl. We are using decision trees because they are a data-driven tool that's going to find combinations of features to determine the underlying patterns within a data set. The clicker doesn't like me and is not letting me pass on to the next slide. There we are, thank you. So to understand what we're doing with these decision trees and why we took this particular approach, we're going to break down our methodology into these three sections. What are we predicting? How are we making these decisions? And how are we evaluating it? So it's important to know that when we're making our predictions, we're not evaluating whether or not someone's case should be taken on. We have no information of unsuccessful cases and more largely people who have never applied for Innocence Project assistance or other assistance in any way. So what we're doing with this information is we're using the decision tree to figure out more information about how underlying patterns can inform class membership given the LCA classes. This is not going to diagnose candidate success, but it's going to guide attention to the information needed for intake staff to make their decision-making process easier and streamline how they're going to approach these cases. The reason that we're using decision trees specifically is that they have an ability overlooked by a lot of big data methods to reveal sort of rare low probability patterns so long as there is a robust number of combinations. And as we'll see in a minute, decision trees are actually quite transparent because we're able to observe the relevant feature at each split and how these features combine. We can also see how they misclassify these cases. And at this time, we're going to focus primarily on discrete and enumerable data, so no ages or lengths of sentences. At this point, it's because we don't have a consensus on how to break down this continuous data. So in the interest of not handling data irresponsibly, we've set it to the side until we can make a more informed decision. And we're choosing to evaluate these using the two factors of precision and recall. So precision is making sure that a model only targets, does it only select the target items? If it doesn't, then we're going to end up with false positives, and a lot of items that shouldn't be in a target group end up in that target group. On the other hand, recall is testing if the model fails to select items from the target group. If not, we get a lot of false negatives and we begin to forget the things that should be within a group. Awesome. So here we can see an example of two zoom-ins on what the overall decision tree would look like. The tree itself is much larger, and I've cut out a few branches for size. And you may not be able to see in the branch in the back, but this is focusing on murder cases that appear in the National Registry of Exoneration. Because we can see this really large spread, we're also going to zoom in on this subtree that focuses on instances where official perjury was not deemed to be a factor in the case. In these small boxes on the side, I've highlighted our terminal nodes where we're actually deciding what member this combination, or what class this combination of features will take us to. We can look, for example, at the investigative corruption box on the left, and we see the numbers below it. That's going to give us our error rate. We see now that there are 132 cases that will take us down this specific branch, and 24 of those cases are being misclassified by the tree. So we get to make a decision about how we handle this combination of features, given the large number of items that belong here, but also the number of items that have been misclassified by the tree. Users of this sort of framework should also be mindful of small subtrees. We can look at the intentional errors box at the bottom, where only 2 people ended up members of this particular group. So at the evaluation phase, this may be a combination of features that we may not be able to make a prediction about. Maybe we can go up the branch and combine this group with the group next to it and just ignore the factor of whether the prosecutor lied or not. But that's something to be mindful of in the moment when we're actually using this tree. So among murder cases, what we do see is that most of these cases are assigned and categorized as investigative corruption or intentional error cases. We can also look at the evaluation metrics a bit more closely. So on the top here, we're going to look at the precision and recall for 2 models. On the left-hand side, the decision tree is given just those 6 canonical factors, and we want to see how well the decision tree is able to learn the latent classes from those same 6 factors and repeat the information. Those 4 blocks in white are going to be the precision and recall for each individual latent class. The one in yellow is going to be the average across all classes. And we see that we have scores above 80, which gives us some confidence in how these 2 frameworks are going to interact. Below that, we have something called a confusion matrix, where what we want is high numbers along that yellow diagonal and low numbers or no numbers in the white space around it. What this matrix is telling us is it's giving us the exact number of cases that if what they actually belong to is that case along the left axis, where the model is classifying them is along the top axis. So here on the left-hand side, we see that we have that very strong diagonal and a very small spread off of that line. On the right-hand side, on the other hand, we're going to have a model where we remove the canonical factors and we reintroduce all of those discrete variables in the rest of the NRE. So that's going to be information about the case, about the location, so on and so forth. And our precision and recall drops, but because we're able to do a bit of an error analysis, it's not at a point where we're concerned about it yet. And we can see from our confusion matrix that the numbers are a bit more disparate. We still have that strong diagonal, but there is more of a spread throughout the rest of the matrix. And as I say at the top, I train these models on 75% of the data, and the evaluations you see here is run on the remaining 25%. So this gives us an idea of how well this model is able to generalize across the data in the NRE. So given what we see about this framework and about what numbers we're seeing, how can this sort of framework be used? Well, like we said, it can be used by intake staff to help inform their decision-making process at different levels of deciding whether or not they're going to take on the case. It's going to make that process data informed even more so than it already is, and hopefully give them places to fall back on if there's something that may have escaped their notice or if they see a parallel between some other cases. What we can hopefully also do is reveal some previously undetected patterns within that data sets. This is going to take a bit more analysis of the tree itself. And we're hoping that we can use a flexible system so that we can fit the needs of framework to the needs of the individual organization. For example, we know that some innocence organizations will only take on cases that have DNA information. So you may want to narrow your scope to those cases. On the other hand, one of the covariates within the NRE is the intervention of an innocence project or a conviction integrity unit. Now, because these decisions are the point at which one of these groups is intervening, we may not want that to be in the predictive model because the intake staff is at the point of deciding whether or not to intervene. So those are decisions to be made along the way. So our next steps, hit the clicker, there we go. So these first three have to do with what our data is going to look like, where we're getting it from. Our first step is to work with the NRE to get more data and learn how to interpret the data that they have. Our second one is to make some more decisions about how to handle these continuous variables that we've set aside for the moment, because that's very rich information that at this point in time, we're not sure how to responsibly and reliably interpret it. And we also want to look at other contextual variables that could inform what was going on in the environment around that particular case. Our fourth step is a strong hope that at some point in the future, we're able to partner with intake staff so that any future development that we make for this framework is in accordance with their wants and needs and is actually benefiting them and making their job a bit more streamlined. Thank you very much for your time.
Thank you, Kalina and Carl. We have someone from the audience, Billings Leah Brand said, great information, and indeed it was. So now we're going to enter our Q&A for the researchers. Let me see if you have any questions. Okay, so here's a question for IPNO. Since your research is focused on analyzing discovery, can you share with our audience some of the issues associated with discovery requests, especially from the perspective of defense and post-conviction attorneys? But first, can you briefly explain what discovery is for individuals that may be unaware of the term?
I think we may have mixed up some terms in naming this the Discovery Lab. We're not actually just looking at discovery documents, which is a reference to documents and information that needs to be turned over by the opposing adversarial side at a trial. We are thinking of discovery more in the sense of going out and discovering things. What was the second part of that question?
I think now that you've clarified that it's no longer relevant, but there is another question for you all. So we heard earlier today about the potential dangers of or challenges with AI tech. You talked about unique potential benefits or opportunities specifically related to intake. How do we strike that balance? What safeguards can we implement? And are there any limitations to this technology?
Thank you for that question. So at the moment, we're striking the balance by focusing solely on public records. The idea by focusing solely on public records is that we don't want any sensitive information being sent to OpenAI or Microsoft or Google that can then be used as training data. We want to ensure that all of information which is potentially sensitive remains sensitive. In the future, we hope to explore the documents which contain sensitive information by redacting those documents ourselves. And one efficient way of redacting those documents is actually by using large language models. That said, we don't intend to use open source large language models like ChatGPT, which has the potential for using our data for training purposes. Instead, we use more closed source models, which might be less effective at extracting information, but should be as effective at allowing us to redact any of the sensitive information, which can, and then that information, once it's redacted, can then be used with some of these open source models, if we believe that the open source models will be more effective at extracting data from these documents. And so that's one or two of the ways in which we're hoping to mitigate some of the issues that arise when dealing with sensitive information.
And with specific regard to reviewing or evaluating cases, that doesn't have to be specifically at the intake stages, could be used by investigators and attorneys working on individual cases as well. I think the greatest potential will be, I can't say that it is because we haven't seen the results yet, in identifying trends over time in specific places, connecting the people involved in all of these cases, and then allowing us to then, as humans, go in and go and find and look at those cases. I'd also like to stress that we're not using AI in any. We're not asking it to predict anything. We're asking it to find things and describe the context of those pieces of information within these documents.
Thank you for the clarification, Wee. So we have some people that are asking us if this video will be recorded. The answer is yes. We're going to publish the majority of the conference in the next few days. Okay. We have Rose H. She said, "Thank you, Innocence Project. I am a recent graduate of Masters of Criminology in, I believe that's New Zealand. Forgive me if I'm wrong. It's the flag. I'm of First Nation descent, and I'm out on bill. I've got some skin in the game. This is fantastic to me. Thank you so much, Rose, for that feedback." So the next question I have is for Carl and Kalina, which is kind of similar to the question I just asked the IPNO team. So your research shows how algorithms can be used to aid individuals who may potentially be wrongfully convicted. However, we do know that there are some concerns that must be addressed when we utilize algorithms and automations or any type of predictive programming. I know that you mentioned that your method is more of an assistant than a replacement, but for those that are wondering, what are some safeguards that must be in place to mitigate algorithmic and automation bias and ensure that there's still, a human component within this process?
Absolutely, Tiba. Thank you so much for that question. I think one of the reasons that we took this particular approach is that there are other systems that are known as black box systems. You can't exactly look into the guts and see at which point a certain decision is made. With a decision tree, like the tree that I showed you, you can see specifically how things are breaking down, and you can compare these different branches, seeing how information will filter to one branch versus another branch. So of course, there's still going to be a case of bias, but it's going to give us an opportunity to look at things more closely, check ourselves, and streamline that process rather than we make no claims that it's going to eradicate it entirely, and we're trying to keep it in mind as we're making these methodological decisions. Carl, do you have anything to add to that?
Yeah, I'd just like to add also that in terms of what we're doing, at no point are we. So you talked about, Tiba, thank you for mentioning the idea that we're not trying to replace any human decision making. And what's really important to know is that our tool has uh, no possibility of doing that at any point. At no stage would it ever tell you anything about a particular individual being more or less likely to have anything happen to them. What we are intentionally doing is trying to make the work of intake staff a bit easier. And we want to meet them where they are and at their needs. And I think that's probably one of the most important things to do. As Kalina mentioned during our presentation, we want to partner with the intake staff so that the development of our framework is in accordance with their needs, so that at any stage, the only thing that we're doing is providing an assistive tool and not something that's going to ever override a human user of that tool.
Thank you, Carl, and we really appreciate your efforts. This is another question for IPNO. So the Library of Congress has been using volunteers for transcription slash data entry, a crowdsourcing campaign. Can that be done here too without violating privacy?
Not only are none of us today doctors, none of us are lawyers either. So the privacy question, I'm not sure about, but I could see this being useful somewhere downstream, especially when we're looking at unstructured data that comes in the form of handwriting. Many of these documents are handwritten, and so I could see a potential use there. But we're having so much fun right now with things that are actually typed and transcribed that we haven't figured that out yet, and that will be our first priority.
Just add to that by saying hopefully we can do away with any manual data entry in the future if the technology progresses to that degree, only because we're working with a small subset of our documents now, which are the documents that have only been digitized, and they still come out to over 300,000 documents and about 30 million pages. We have an abundance of documents that are in storage, which haven't even been digitized yet. So thinking in the future about just the sheer volume of documents that we'll be working with, I think we'll continue to look for ways in which we don't have to rope in any or any group of people to do manual annotation.
Great, thank you. A lot of great work that has already been done and more to do. So this is kind of for both research teams. Can you talk about working with disciplinary teams? Are there any benefits, challenges? How does it change the final product?
I'd love to answer that question, and just to emphasize, or just to talk about our the program that Kalina and I are coming from. So we're from Stony Brook, a part of the BIAS NRT program, which is a training grant that's funded by the National Science Foundation, bringing together graduate students from various background disciplines. And so I'm currently pursuing a PhD in psychology, and Kalina is doing her PhD in linguistics. And so I think what's really exciting about interdisciplinary work is that Kalina and I would have probably never crossed paths in our graduate education at all had it not been for this training program. But in doing so, we were able to, just through conversations, very quickly find an avenue to really exciting work. And I think when you have people that have knowledge in particular domains, when you're pursuing a graduate career, what you find is that people can sometimes get a bit pigeonholed, or they can get tunnel vision into a particular line of focus. And what's great about interdisciplinary work is you have such specific capabilities in one area that as soon as you start to talk with somebody who's in another area who has other specific capabilities, you can create some really innovative ways to solve a problem. I don't know anything about decision trees until I started working with Kalina. And I think what's really exciting is I've learned so much over this period of time. And what we were able to do was just sort of come up with this project in a singular meeting. I think it's great that it can come up so quickly. As soon as you start getting people that have specific knowledge working together, really innovative things can happen very quickly. And I think that's a wonderful benefit of interdisciplinary work.
I want to give time for the New Orleans folk to respond to this question as well, but just piggybacking very quickly over something that Carl said that I really want to hammer in. Nothing that I showed you today, nothing that either of us showed you today was linguistic. I come from a linguistics background, but the interdisciplinary exchange that we have here was that I knew a tool that I had used in my own research. And through conversation, we were able to extrapolate and see what can we do with that tool in this completely unrelated domain. So even though I consider this far out of my field, to go off of what Hoy had said, I'm not a doctor, I'm not a lawyer, I'm also not a psychologist, and I don't work in criminal justice whatsoever. But I like to think that through these conversations, we were able to unlock ways of thinking that none of us had ever considered. I'd like to hand it over to the New Orleans crowd for that.
I'll just say quickly that I don't think there's anything more we could say that Carl and Kalina haven't already demonstrated really clearly. So I don't want to burn any time further on this question, unless we or Ayub, you have something you want to add? No, but really, yeah, I couldn't imagine working any other way.
That's great. We still have some more time. So one more question. So for anyone who's interested in being involved, either in the innocence movement or providing any type of assistance, from your perspective, what are some things that they can do directly or indirectly to assist? This is for anyone.
Well, if we're going to tie it back to, I guess, the point and title of today's conference, it's actually to engage in their communities. All of this gets tied together back at the community. Like when we're talking about policing, we're talking about communities that are being policed. When we're talking about policy and law, we're talking about policies and laws that affect communities, and certain communities more than others. We just happen to be dealing with the wrongfully convicted community, which is a thing of its own. But I would encourage people to take whatever they've learned here today and think of them not as, things they have to learn, but tools that they need to learn how to use in order to advocate both for themselves, for the wrongfully convicted, for anybody who is touched by the criminal legal system, and for informing the people they elect, and then when taking those people to task for the things that they pass.
Would anyone like to add on? No? Awesome. Thank you so much. I hope everyone in our audience enjoyed the presentations. I know I did. We are going to close out this session now. So we do have a break coming up. I believe it's about 11 minutes. So stay tuned.